Have you ever noticed how some objects or shapes look the same from different angles or orientations? This is what we call symmetry. Symmetry is a fundamental concept in mathematics and science, and it plays a crucial role in many areas of our lives, from art and design to physics and chemistry. Symmetry refers to the property of an object or a system that remains unchanged under certain transformations, such as rotations, reflections, translations, or combinations of these. For example, a circle has rotational symmetry because it looks the same after rotating it by any angle around its center. A square has both rotational and reflectional symmetry because it looks the same after rotating it by 90 degrees or reflecting it across any of its four axes. Symmetry can be described and analyzed using the language of groups. A group is a set of elements or objects that can be combined or transformed in certain ways, such that the result is still a member of the group. Groups have many properties and structures that make them useful for studying symmetry and other mathematical concepts. One important property of groups is closure, which means that the combination or transformation of two elements in the group produces another element in the group. For example, the set of integers under addition is a group because adding any two integers gives another integer. However, the set of integers under division is not a group because dividing by 0 is undefined and not a member of the set. Another important property of groups is associativity, which means that the order of combining or transforming elements does not matter. For example, a plus b plus c equals a plus b plus c for any elements a, b, and c in a group. This property allows us to simplify and generalize many mathematical expressions and proofs. Symmetry groups are groups that describe the symmetries of an object or a system. For example, the symmetry group of square is the group of all rotations and reflections that leave the square unchanged. This group has 8 elements, corresponding to the 4 rotations by 90, 180, 270, and 360 degrees, and the 4 reflections across the horizontal, vertical, and 2 diagonal axes. Symmetry groups can be represented and visualized using group tables, Cayley diagrams, or other mathematical tools. These representations help us understand the structure and properties of symmetry groups and how they relate to other mathematical concepts and applications. In the next segment, we will explore some examples and applications of symmetry and symmetry groups in different fields of mathematics and science. Stay tuned. Now that we have a basic understanding of symmetry and symmetry groups, let's explore some examples and applications of these concepts in different areas of mathematics and science. In geometry, symmetry plays a crucial role in the classification and analysis of shapes and structures. For example, the Platonic solids, which are regular polyhedra with identical faces and vertices, have symmetry groups that correspond to their rotational and reflectional symmetries. These symmetry groups have important applications in crystallography, chemistry, and physics, where they describe the symmetries of molecules, crystals, and other materials. In algebra, symmetry groups are used to study the properties and structures of equations and functions. For example, the symmetry group of a polynomial equation is the group of all permutations of its roots that leave the equation unchanged. This group has important applications in Galois theory, which studies the solvability and complexity of algebraic equations. In physics, symmetry plays a fundamental role in the laws and principles that govern the behavior of matter and energy. For example, the laws of conservation of energy, momentum, and angular momentum are based on the symmetry properties of physical systems under certain transformations. These symmetries have important applications in particle physics, cosmology, and other fields of modern physics. In art and design, symmetry is a powerful tool for creating aesthetically pleasing and harmonious compositions. For example, the use of symmetry in architecture, painting, and sculpture has been a hallmark of many cultures and styles throughout history. Symmetry can also be used to create optical illusions and visual effects that challenge our perception and cognition. In conclusion, symmetry and symmetry groups are fascinating and versatile concepts that have important applications in many areas of mathematics and science. By understanding and appreciating these concepts, we can deepen our understanding of the world around us and the beauty and complexity of nature and human creativity.